Thank Thank you so much for the invitation. I would like, in fact, also to thank you and also the person who are there. Um, I would like to start with the lateral thinking as a tool for the problem solving. So the idea is to get another point of view, so we don't have just yes, no, but maybe this object. I will define it after. But the idea is to try to find, when we have a problem, a new solution. So the idea of De Bono was to find new angles to solve a problem. So these angles are very important to understand that we can have a new approach. So, for example, we can use an experimental model, which is in fact a thought experiment. And imagine a new problem with a new situation. So sometimes many things looks obvious. So we have to define the idea that obvious is not a fact. So we can think only about facts, but not obvious. Many things are obvious because we don't ask somebody to explain why it's obvious. For example, the sky is blue. It seems to be obvious. Why? In reality, we have to define the polarization of the light to prove that it's indeed blue. So the idea is to have some techniques, and one of them is to have an idea with generating tools. So imagine that you want to solve a problem. So for example, you have a problem and you think that the solution is here. So this is your behavior. The question is if your behavior depends more from the problem than the solution. So the idea is to define some obstructions. So now imagine that you have a situation like this, you have an obstruction and you want to go there. The first idea is to do this. Okay, but this is impossible. So we have an obstruction. It looks obvious that we should do this. This part is not so obvious. Why? Because you go far away from the solution. So in fact, this is an innovation. This is the normal situation. So if you want to find something, and if you want to get the solution, the first thing is to find the obstructions. So imagine now that you have many obstructions, and you have to do this to go there. Your behavior depends, in fact, to that and not to that. So the solution the solution is not a resolution. So if you want to solve a problem, you don't try to find the solution. Just think out of the box, of course, and imagine that the problem is in a frame. So you have to define this frame, you have to define the field of action, and the battlefield. So the solution is only at the end. The idea is how to go from here to here and next point. So we have the idea of the successor. So we are in a frame. It looks like a box. But now imagine that you have an open mind and you don't want to restrict your thought on this area. So maybe I will give you an example and we will do it after that. So imagine that I show you this. So this is a frame. This is a frame. Okay. So this is fixed. And we want to put in this frame those things. So we have 4 things which are exactly the same. The idea is to identify the frame and to see that this one, this side, is the easy side, and this one is the difficult side. Okay? So, but the problem is only about the piece. So, in fact, we have to put the piece inside the box, but we have 4 pieces, and we don't want an overlap. So it seems to be very easy. Let's consider this problem. So I have a frame. I have 4 pieces. I want all of them inside. The first idea is to try. So we try. It's not obvious. And after that, the concept is if I am outside the box and I just want to see how I can make a combination of those 4 pieces. In fact, I want to get something which is optimal. And by the way, related to something which is robust. So I will try to have what? A new geometry, a little set. And if I try with the 4 pieces to do something which is optimal, at the end, I will get also the result about the box. So firstly, we can use it as a random and try idea generation. So you can think something which is different. So for example, we have here a square, but we can put a rectangle or something which is different. You want to solve a puzzle, for example. Imagine a classical puzzle. You want to do what? You will do the four corners, At the end of that, you will get the edges, and you will go from that size closer to the center. Okay? But now imagine that the problem, so I will show you some pieces like this. The problem is that the edge is not a rectangle. So imagine that you have an ellipse and you want to solve the problem with the ellipse. You will have a problem where, in fact, to all the corners, because there is no more corners, we don't have any edge, it's different. So we are talking about, in fact, something which is more topological than geometrical in an easy way, and we will have to think about the notion of boundary. You will see it after that. So imagine now a new idea. You have a focus tool, okay? So the idea is to find a new idea. So don't worry if the new idea is wrong, because a wrong idea can be useful. A good idea sometimes is useless because it's not related to the problem. So for example, imagine that you are on a chessboard and you have a queen, and you know that the queen represents 9 points. Okay, what is the value of the queen outside the chessboard? In fact, it's 0. So the question, if someone is asking you, do you prefer to be the queen or the pawn? It seems obvious to choose the queen. But the real question is if you are in the chessboard or not. So now if I ask you, do you prefer to be a pawn on the chessboard or a queen outside the chessboard? It's exactly the same for the job. The idea is here is related with your brain, and here is related with the job. So we can have a very good job, a very nice job, but it's not related to your brain. So at the end, you will give up. So the idea is to find something new. To find something new doesn't mean correct. It can be, at the first level, insane. Why? Because you want to break the routine. And to do that, you need a new concept. So this concept has to be free. So all of you, I imagine, you know the problem of Minsky about the 9 points. So the idea is to think out the box. So when you get that, you are thinking that, okay, it's another problem with the square. But the idea is to go outside and to go against inside in different manner to solve the problem. We need for that another idea, is the provocation. For example, for the moment, I'll let you doing what you want. So I don't ask you any question. If now I start to ask you questions, you would change your behavior. But hopefully, for you, I will not do that because I have to finish the first part. So don't worry, you can continue to do the same thing. I will not ask you any question, but at the end, I will see if you understand the absence of questions. So the treatment, it's the same thing, tools. So this is in relation with the real world constraints and the resources and the support. So imagine that you want to solve a problem. Okay, so imagine this one. I'll give you 5 pieces and I want to create a square. At the end, I will give you only 4 pieces to create another square. And the question will be, in fact, if this problem is related or not to the real world. So in fact it is, but it seems a little bit theoretical. So imagine now that you have the theory and you have the practice. Remember a word of Einstein, if you want to go from the practice to the theory, it's impossible. But you go to the theory to the practice, it's possible. So in fact, in this challenge, we can think the problems in a quite different way. So I will give you an example. Don't worry if it is tough, but it's easy at the first glance, of course. So you have the numbers 1, 3, 4, and 6, only that, okay? You can use, of course, plus, minus, or the classical operation, okay? And from those numbers, you want to get 24. That's all. So imagine now how many minutes you will try this problem. So maybe for you it's obvious, but if you care about that, you will see that it's not obvious, but it's a fact. You can do it with techniques, but the idea is, what shall I do with a so simple data to get a so simple result, and why it's a problem? So for that, you can imagine that the lateral thinking connected in the brainstorm framework can be very efficient even when the problem is not obvious. So if you are thinking with this kind of movement techniques, you can get some solution which are in fact totally different from the initial solution. So this is a point. You can use serendipity. So serendipity, in fact, is the idea you can find something that you are not searching. So it's a new idea. You can use it to find new solution. So imagine again the 8-queen problem. You have to put 8 non-attacking queens in a chessboard, and my question is not to find one solution. I don't care. I want just the second one. And you will see that it's rather easy to find one solution, but it's difficult to find another one which is different. Why? Because this one is natural, and this one, for you, for example, is artificial. So sometimes it's good to imagine that the good solution maybe is artificial and not natural, because the natural will work in a space which is smooth, but the artificial will work also in a singular space. That's all, guys. Thank you for your attention, and I hope you will try something new with your life and your studies also, and of course your job.
Thank you very much, Mr. Lygeros, for your lecture. As we said before, it was really our pleasure to have you with us today via Zoom platform. So thank you for all the knowledge, all the out of the box.
Thank you. Thank you. It was an honor for me. Thank you so much. Thank you so much.
Now we'll do some practices of the mind games that you have.
Thank you.